Now let's move to another routing scenario. This time we have two routers called headquarters and branch office. If we look at their routing table, you will find that headquarter router has two interfaces, Fast Ethernet 00 and Fast Ethernet 01. Network 192.168.10.0/24 is configured on Fast Ethernet 00, and 1.1.1.0/24 has been configured on Fast Ethernet 01. Branch office router also has two interfaces, Fast Ethernet 00 and Fast Ethernet 01. Network 192.168.10.0/24 has been configured on Fast Ethernet 00 and 2.2.2.0/24 has been configured on Fast Ethernet 01. Each router has a routing table with only his directly connected interfaces. Starting from now, I will use HQ router instead of headquarters router and BO instead of branch office router. So, what about if HQ router wants to know about the network 2.2.2.0/24 behind BO router, and BO router wants to know about the network 1.1.1.0/24 behind HQ router? To reach that, we have to make it into the routing table somehow. After making that, HQ router and BO router know about these networks behind each other. There are two ways to make the routing table on each router to learn this information: the static routing and dynamic routing. If you use static routing, you will have to do everything yourself. You tell the router where to send IP packets for a certain network. It's a lot of work. Dynamic routing means we use a routing protocol that will be responsible about exchanging the network information between routers. Let's start with the static routing. Here we have a network with two sides, headquarters and a branch office. We want to make sure that both networks can reach each other. Let's start by configuring those routers' interfaces with the IP addresses. And don't forget to do a no shutdown on the interfaces. Let's do it. Now, let's view the routing tables of both routers using the show IP route command. This is what a router uses to make decisions where to forward IP packets to. By default, a router only knows its directly connected networks, as we learned that in a previous video. We configured an IP address with a subnet mask on the interface, so the router also knows the network address. Router HQ knows about network 192.168.10.0/24 and 1.1.1.0/24. Router BO knows about network 192.168 2.10.0/24 and 2.2.2.0/24. At this moment, our HQ router has no idea how to reach network 2.2.2.0 because there is no entry in the routing table regarding this network. What will happen when we try to reach it? Let's check. Ping 2.2.2.1. The ping failed. This router checked its routing table and discovers that it doesn't know how to reach network 2.2.2.0, so it dropped the traffic. Now, let's use a static route to tell HQ router how to reach this network. To create a static route, we use the iproute command. Let me break it down for you. 2.2.2.0 is the network we want to reach. 255.255.255.0 is the subnet mask of this network. 192.168.10.2 is called the next hop IP address. It's the IP address where we want to send traffic to. In this example, that's the branch router IP address. So here, I'm telling the HQ router that it can reach network 2.2.2.0 by sending traffic to IP address 192.168.10.2, which is our BO router. Let's take another look at the routing table to see if anything has changed. As you see, now we can see an entry for network 2.2.2.0/24 in our routing table. Whenever HQ router has traffic for network 2.2.2.0, it will send it to the IP address 192.168.10.2, which is the BO router. Let's see if our ping is now working. Ping 2.2.2.2. Yes, it's working, because now the HQ router knows how to reach network 2.2.2.0 through our static route. Now we will do the same configuration on BO router to make it reach network 1.1.1.0 behind HQ router. Now it's ready. Let's ping 1.1.1.1. Yes, it's working. So, whenever an IP packet arrives at a router, it will check its routing table to see if it knows about the destination network. If it does, it will forward the IP packet, and if it has no idea where to send traffic, it will drop the IP packet.